Hello everyone, we are solving problems on the mesh analysis and nodal analysis. In that, next question is find R1 and R2 for the circuit shown in the below figure. This is the given circuit. If you observe this circuit, this branch current is 10 amps. That means here if you consider this node, this current is leaving this node. Okay, this is 10 amps. Now here it is 5 amps. This branch current is 5 amps, so it is also leaving this node. This 5 amps is leaving this node. Now consider this current I1, apply KCL at this node 1. Let it be node 1 by KCL at node 1. What is incoming current? I1. So I1 is equal to, what are the leaving currents? This 10 amps and 5 amps are leaving. So 5 plus 10 or 10 plus 5 is equal to 15 amps. Now current is entering to this 2 ohm resistor here. Okay, this is top to bottom. So current is entering here. So it is plus and it is minus. Now what is voltage across 2 ohms? V is equal to I1 into R. What is I1 here? 15. R is 2 ohms. So this is 30 volts. That means the voltage across this 2 ohm resistor is 30 volts. So that means here the node voltage is 30 volts. Now let it be current I2. So what is the current I2 now? I2 is equal to, here this node voltage is 100 volts. This node voltage is 100 volts. So 100 minus 30 by 14. So this is 70 by 14 is equal to 5 amps. See, the current I2 means, see, this is 100 volts. That is, for suppose 100 volts is like this, and this is 14 ohms. This 30 volts, this node voltage is 30 volts. This node voltage is 30 volts. That means the circuit exists like this. Okay, we are finding current I2. So this is 14 ohms, this is 100 volts, and this is 30 volts. Now what is I2? By KVL, it is 100 minus 30 is equal to 14 I2. From this, what is I2? 100 minus 30 by 14. Here we are getting same thing. So this is 5 amps. Now this node is 2. Apply KCL at node 2. Let it be current I3. So by KCL at node at node 2. What is the current? So this is incoming current 10 amperes. I2 is equal to 5 amps. We got 5 amps. These two currents are leaving the node and this current is entering to the node. That is 10 is equal to 5 plus I3. From this, what is I3? I3 is equal to 5 amps. Now we got current flowing through this resistance. We got current flowing through this resistance, that is 5 amps. I3 is 5 amps. Now what is the voltage across resistance R1? So this is connected across this node and this node. So voltage across this resistance is this minus this one. That is, or you can apply KVL for this loop. You can apply KVL for this loop. Then you will get 100 minus 40, because this node voltage is 40 volts, is equal to I3 R1. So I3 is 5 amps. So 5 R1 is equal to 60. R1 is equal to 12 ohms. Now coming to here, let it be current I4. So this current is coming towards to this node and this current is coming towards to this node. Let it be node 3. Okay, by KCL at node 3. So these two currents are coming towards to this node. So I4 is equal to 5 plus 5, that is 10 amps. What is the voltage across resistance R2? The node voltage is here is 40 volts. The node voltage here it is 30 volts. So VR2 is equal to 40 minus 30. It is 10 volts. So this is plus, this is minus because it is 40 volts. So 40 is greater than 30. So it is plus and it is minus. Now R2 is VR2 by I4. So that is 10 by 10, that equal to 1 ohm. Next question is find VA by VB. This is the given circuit. Here the voltage across these terminals is VB. That means here this node voltage is VB. Voltage across these terminals means here it is reference node. So this the voltage across this node is VB. Now apply nodal analysis at VB or write the node equation at VB. Okay, node equation at VB is, for this branch, VB minus VA by R. For this branch, plus VB by R. So this current is coming towards to the node. Okay, this is current source, dependent current source, and this current is coming towards to the node. So it is minus beta I is equal to 0. Now let it be equation 1. By Ohm's law, what is I? I is equal to VA minus VB. So this is positive. So VA, here also it is positive and this is negative. It is VB. So VA minus VB by R. So from 1, what we are getting? VB minus VA by R plus VB by R minus beta into VA minus VB by R is equal to 0. So here R gets cancelled. So you will get equation VB minus VA plus VB minus beta VA plus beta VB is equal to 0. So you will get 1 plus beta into VA is equal to 2 plus beta into VB. So VA by VB is equal to 2 plus beta by 1 plus beta. Next question is find current I in the following figure. This is the given circuit. So the voltage across 2 ohm resistor is VAB. That means here this node voltage is VAB. The voltage across 2 ohms resistance represents the node voltage of this one. Okay, this is VAB and this is reference node. So by nodal analysis, write the node equation for VAB. So VAB by 2 minus, so this current is coming towards to this node. So if current is coming towards to the node, that is minus. So minus 4 plus VAB minus 5 VAB by 3 is equal to 0. 3 VAB minus 24 plus, so minus 8 VAB is equal to 0. From this, VAB is equal to minus 4.8 volts. So here it is current. Now what is the current? Current I is equal to, by Ohm's law, VAB minus 5 VAB by 3 is equal to, so this is minus 4 VAB. VAB is minus 4.8 by 3. So you will get I is equal to minus into minus plus 6.4 amps. Next question is find current I in the following circuit. This is the given circuit. We can solve this circuit by using either mesh analysis or nodal analysis. Okay, I will solve this circuit by using both the methods. So method 1 is nodal analysis. See here, the voltage across this 1 ohm resistance is VA. That means the control variable is VA. So this is reference node and this node voltage is VA. Write the node equation at VA. Write the node equation at VA. So VA for this branch. So in nodal analysis, we assume the node voltage is highest value compared to other voltages. So the currents are, all currents are leaving from this node. So this current is leaving this node, this current is leaving this node, and this current is leaving this node. So what is the current here? VA. So it is minus. It is minus, so consider it here plus. VA plus 2VA, and this is positive. So this is positive means here minus by what is the resistance? 2 plus VA by 1. This current is coming towards to the node, so it is minus equal to 0. So 3VA minus 8 plus 2VA minus 6 is equal to 0. By solving, VA is equal to 2.8 volts. Now what is the current? Current I is equal to, current is leaving the positive terminal, so here it is 8. Here the current is entered to the positive terminal. Okay, this is current is entering it to the positive terminal, so here it is minus 2VA, and here this is positive terminal, current is entering here, this I current is entering here, so it is minus VA by the resistance is 2 ohms. So this is 2. So you will get this is 8 minus 3VA. VA is 2.8 by 2. So by solving this, you will get minus 0.2 amperes. Now method 2, mesh analysis. Here for this mesh, okay, this branch current represents this mesh current, so that is I, let it be mesh A. So same current is flowing through this branch, this loop current is flowing through this branch, so here branch current is given as I. Here also this is this loop current, this branch current represents this loop current, this is 3 amps. So write the mesh equation for loop A. So what you are getting here, the current is leaving the positive terminal of source, so it is plus. So one more source is there, that is dependent source. So dependent sources also coming under sources. Okay, consider whenever you are applying mesh analysis, depending source also considered as a sources. For this source, current is entered positive terminal, so it is minus 2VA. Minus 2VA. So all sources are completed for this loop. Now what are the passive elements? This is one passive element and this is another passive element. So this, for this passive element, what is the current? So that is current is I and resistance is 2. So 2I plus, so for this is 1 ohm, 1 into, this current is coming from top to bottom and this current is also coming from top to bottom. So this is I plus 3. So what you are getting? 3I is equal to 5 minus 2VA. Let it be equation 1. Now here the current control variable is given here, that means VA. So what is a VA? VA is equal to, so current is by KCL, this is I and this is 3. So what is the current flowing through this branch? 3 plus I. 3 plus I. So here it is 1 into 3 plus I. From this, what is VA? VA is equal to 3 plus I. From equation 1. So 3I is equal to 5 minus 2 into 3 plus I. From this, 5I is equal to minus 1 and I is equal to minus 0.2 amps. Next question, determine the node voltage V1 for the circuit shown below. This is the given circuit. Here this is node voltage V1 and here one more node is there, this node voltage is 5 volts because this is the reference node. Okay, this is reference node. So from here to here the voltage is 5 volts because these two are in parallel. So the voltage across 20 ohms is 5 volts. That represent the voltage at this node is 5 volts. Now write the node equation for V1. Write node equation for V1. So what you are getting? V1 minus 100 by 4 for this branch plus V1 by 2 plus V1 minus 5 by 8 is equal to 0. For this branch, V1 minus 5 by 8 is equal to 0. 2V1 minus 200 plus 4V1 plus V1 minus 5 is equal to 0. So what is the V1? 7V1 is equal to 205. V1 is equal to 205 by 7 volts. For suppose if we increase this resistance value from 20 to 40, so what is the V1? Again V1 is same value because this node voltage does not depends on this 20 ohms. So whatever may be the voltage across voltage source, that is ideal voltage source, the voltage does not changes. So see, we are getting same voltage even though we are changing this 20 ohms. Okay, in the next video we will discuss some more problems. Thank you for watching.